I've already shown most of my working out on the screen here, and I'll just talk you through it. So we have the two parametric equations here, and we need to show that the gradient function is 2t minus t squared. So we know parametric differentiation. We know we're going to differentiate the y with respect to t, and then differentiate the x with respect to t, and then divide them. So in blue, this is me differentiating the y function. Now we need to be super careful here because this is a fraction, so we need to use the quotient rule. So you can see that I've said that the u is the t squared minus 2t plus 2 from the top here, and I've said the v is the t minus 1 from the bottom here. We're going to differentiate each of those, so differentiating the t squared minus 2t plus 2 gives 2t minus 2. So that's my u dash. Differentiating t minus 1 will just give me 1, so that's my v dash. Now to apply the quotient rule, we're going to have u dash times v, so that's this, minus v dash times u. So 1 times all of that, so that's that. And all of that's divided by t squared. Next, I've simplified, so I've expanded these brackets here. And I've expanded these brackets here, being super careful with these double negatives. Next, I've collected up the like terms. I've got the 2t squared minus t squared. So that's just t squared. The minus 4t plus 2t is minus 2t. And you can see the plus 2 and the minus 2 cancel out. And then I've just factorised my numerator a little bit there as well. So that is the dy by dt. Then in red, I've done exactly the same thing with the x function. So quotient rule, I've said the u is the 3t minus 2, because that's what we've got on the top here. And I've said the v is t minus 1, because that's what we've got on the bottom here. Differentiate the 3t minus 2, we get 3. Differentiate the t minus 1, we get 1. Apply the quotient rule, so u dash times v minus v dash times u, all divided by v squared. Expand the brackets, so we get a 3t minus 3 and a minus 3t plus 2. The 3t's cancel out, the minus 3 and the plus 2 give a minus 1. So this is my dy by dt, which I'm going to plug in here. And this is my dx by dt, which I'm going to plug in here. So that brings us to this line here. Now, dividing fractions, I'm going to multiply by the reciprocal. And now we can see that the t minus 1 squared and the t minus 1 squared are going to cancel out, which is going to leave me with the t times t minus 2, all divided by the minus 1, which if I just expand that out, and dividing by minus 1 will make a minus t squared and a plus 2t. And that's what we needed to show. So that's part A of this question done. Moving on to part B. We're told that the point P, which has got the coordinate 1 minus 5 over 2, lies on the curve. And we need to show the equation of the tangent. So I'm thinking y equals mx plus c. And I'm thinking I want to use the gradient function to work out what the gradient of the tangent is going to be. The problem is I don't know what t is at this point, but that's fine because I know that the x coordinate is 1. So if I plug that into my x equation, so that's what I've done here. I could, if I wanted, Instead, if I wanted to substitute the y into the y equation, I could do that, but I just didn't fancy the look of the minus 5 over 2, and also we've got a quadratic over there, so I thought that was going to be a bit more complicated than looking at the x function. So I've then solved this equation by multiplying by the t minus 1. That gave me this line. Solving that equation gave me that t is being 1/2 when x is 1. I've then plugged the 1/2 in here and here to find out that the gradient of the tangent at that point is 3/4. So I've then done y equals mx plus c, knowing that the x coordinate is 1 when the y coordinate is 5 over 2, minus 5 over 2. So just plug in that coordinate in here. Then taking the 3 over 4 away from both sides, so minus 5 over 2 minus 3/4 gives me the minus 13 over 4, so that's my c, which I've plugged in here, and then I've just rearranged that equation to get it in the form that we needed.